So each of the following 4 large congruent squares is subdivided into combinations of congruent triangles or rectangles and partially shaded. What percent of the total area is partially shaded? So I think we're finding a fraction for each square and then adding all the fractions together. So what would the first one
is?
Let me know.
Okay, the first one is basically 1/4. 1 is shaded out of the 4.
Yeah, 1/4. For the second box, what fraction would you give the shaded area?
I'd say 1/2/4, but I'm not sure if that makes sense.
Actually, yeah, that does make sense. So you can multiply. So you know that once each square is 1/4. So if you want to find what 1/2 of 1/4 is, you multiply those fractions. So if you do 1/2 times 1/4, you multiply the top and the bottom, and you get 1/8.
Mm-hmm.
So this one, the second box, would be 1/8.
Okay, sure.
And then what about the third box? What do you think?
It's 1.5/4, which is basically so we do 1.5, which is an improper fraction, 3/2, then times 1/4, then 3/8. So it's 3/8.
Perfect. Great job. And then the last one is simple.
Is 1/4, yeah.
Well, if each box, we've been counting each square as 1. Mm-hmm. So if you add up the total area of each square, you get 4. So I think so if you divide 1 by 4, you can get the percent.
0.25.
Perfect.
Yeah.
So that would be 25%. So we get C. Danica wants to arrange her model cars in rows with exactly 6 cars in each row. She now has 23 model cars. What is the smallest number of additional cars she must buy in order to be able to arrange her cars in this way? So basically, you want to make sure that the total number of cars is a multiple of 6, meaning that it can be divided into into groups of 6 with no extras. So what's the closest multiple of 6 to 23?
4.
Yeah, 24, right?
Mm-hmm.
So
since Danica's 1 off, probably she would have to buy 1 more car, so that it would be 666.
That's perfect. So yeah, so the answer is A. So a sign at the fish market says 50% off today only. Half pound packages for just $3 per package. What is the regular price for a full pound of fish in dollars?
Is it 6? Because it's the half.
It would be 6, but the question is asking how much would a full pound be, not a half pound. Okay. The half pound with the discount is $3. So that's still not going to be the price of a full pound, because a full pound would be double a half pound.
Okay, so would it be 12 then, since it's double, or wait?
Yeah, I think it is 12. So that would be D. Nice job. Let's finish here. And yes. Okay, what is the value of 4 times all those numbers added? But you start, okay, so it's alternating between a positive and a negative. So for these types of questions, it's pretty much impossible to actually add them all together.
Okay.
So you have to look for like some type of pattern that makes it easier to add. So see if you can find out like a pattern, or
it's like minus, plus, minus, plus, minus, plus, minus, plus, yeah.
Anyway, you could think of like how to add it a little bit easier. What's -1 plus 2 is 1. Right?
-1, yeah, it's 1.
And then what's -3 plus 4?
Oh, 1.
So like you see how like every two numbers, their sum is 1. For every two numbers, the sum is 1, basically. And it doesn't matter which two numbers it is because they're all 1 apart from each other. So you can divide, if there's 1,000 total numbers and each pair of 2 is equal to 1, then you can divide 1,000 by 2 and you can get
just 50.
Or
then
500.
Yeah.
And then you can multiply by 4.
4, so that'd be 2,000.
Yes, I think that's correct. Yes, it is. Nice job.
Okay.
Those questions are tricky because sometimes you just have to look for like a shortcut, basically.
Okay.
A fair coin is tossed 3 times. What is the probability of at least 2 consecutive heads? They want you to write out every single possibility. You just have to like write them out. So let's try writing them out.
Okay, so
you could do head, head, head. That works. Tail, head, head. What are the other head, head possibilities? Right.
Head, head, tail.
Yes, I think that's the last one.
Yeah.
So those are the only ones that could work. And then the way that you would find out the amount of total possibilities is, so there's 2 possibilities for each space, only 2. You take 2 to the power of 3 because there's 3 spaces. So
Okay.
if it was actually like a special, or if it was like a dice that had 6 sides, you would have to do 6 to the power of how many spaces there are. So if you do 2 to the 3rd power, you get 8, and then you can do, we found 3 possibilities, so 3 divided by 8. If 3 to the p plus 3 to the 4 equals 90, 2 to the r plus 2 plus 44 equals 76, and 5 to the 3rd power plus 6 to the s power equals 1,421. What is the product of p, r, and s?
I figured out what P was. P is 2. I'm trying to figure out what R is.
What did you get for for P?
I got 2 because
Yeah, that's perfect.
3 to the 4th is 81, right? And 90 minus 81 is 9, which leaves P to be 2 because 3 to the 2nd power is 9.
Perfect.
Yeah.
And so we just do the same steps for the other 2, and you should get answers for R and S.
R is 5, actually.
Perfect.
So it's, yeah. And S is, well, 5 to the 3rd power is 125. So 1,041 minus 125 is 1,296, meaning that 6 to something should make that big of a number.
Yeah, and honestly for this one, I just kind of like, it's tough if you don't, like it's tough if it's a big number, but you can just use reasoning kind of, like 6 squared is 36. So 36 times 6 is somewhere.
It's 216. So 36 times 36. Maybe. Wait. Yeah. So it should be 6 to the 4th. So S is 4. So P is 2, R is 5, and S is 4. So what is the product of all those? Should be 40. So B.
That sounds good to me. Let's check and make sure. Yep. Nice job. Okay. A 1 times 2 rectangle is inscribed in a semicircle with the longer side on the diameter. What is the area of the semicircle? We should probably draw a picture for this one. That seems like it would be helpful. So you know what it means for a shape to be inscribed, right? If it's inscribed inside of another shape, its four corners are going to be touching the edges of the semicircle. So I'll show you my drawing. You see how the like corners are like touching?
Mine isn't. No, it's like ish.
Yes, exactly. So you can use like one of the corners of the rectangle that's on the round side and then draw it to the middle of the diameter or the flat side. And then you get the radius. It's the square root of 2. So we just write it as that, but what's going to happen when we put that number in the area formula is that we're going to square it. So then the square root will go away and we'll just get 2. So if we plug it, so for a semicircle, you find area divided by 2, right? So you plug it in with square root of 2 as the radius.
I think it's pi, I think.
Yeah.
Yeah, it's pi. Okay.
So yeah, the answer is C, and they agree with us. Toothpicks are used to make a grid that is 60 toothpicks long and 32 toothpicks high. How many toothpicks are used all together? The tricky part of this problem is like accounting for the toothpicks that are on the inside. So I think maybe first we can like write an expression for the number of toothpicks. So first of all, we have the toothpicks on the outside, right? So we could do like 2 times 60 to get the perimeter plus 2 times 32.
Okay, 120 plus what is it? 64, which is 184.
So we've already taken care of these ones. The outside. Wait, can you see my cursor?
Yes, I can see it.
Okay, so we've taken care of these ones, but we haven't taken care of any of these. So how many vertical like toothpicks are there?
Vertical toothpicks. 32.
Well, so let's just pretend that, forget about 32 and 60. Let's just pretend this is like 4, because that's how the drawing works out. And then this would be 2. Let's just pretend it's 4 by 2. So how many, just in one row, so not looking across the whole thing, just in one row, how many vertical toothpicks are there, excluding the perimeter? So just like these ones.
These.
Yeah. So we could have, so vertical across, we've got 1, 2, 3. And that correlates to a side that has 4. So we can tell that the number of vertical toothpicks in a row is going to be the length minus 1, right?
Mm-hmm.
So we take that number, and so if we have 3 here, because the length of the other side is 2, we have to multiply 3 times 2. So let's pretend that we translated this to 60 and 32. So on the side that's length 62 or 60, how many vertical toothpicks would there be? It would just be like 1 minus. There would be 59 vertical tooth. You see how like the ones that I circled? There would be
there.
59. So we can add that to our expression. So we have 59, and then that's just in one row though. To find the total number of vertical toothpicks, you'd have to multiply that times the length.
So you multiply that.
The other length. So it would be 59. So in this case, in the drawing, it's 3 times 2. In our case, it would be 59 times 32.
Mm-hmm.
To find the number of total vertical toothpicks.
Mm-hmm. Which would be 188. Oh, wait, 1,888.
Oh, nice. So then, so then we do the same thing for the horizontal ones. So in
Okay.
2 minus 1 is 1, right? So we get 1 horizontal, and then we multiply that from the length of the other side, which is 4. So 1 times 4 is 4, and that's how many horizontal toothpicks. So in the problem, we've got 31 toothpicks, 31 horizontals times 60.
Okay.
And then if we add up our entire expression that includes the perimeter, the vertical toothpicks on the inside, and the horizontal toothpicks on the inside,
Okay.
we should get the correct answer. We get 3,932, which is answer choice E. Let's see if we're correct. Please be correct. Yay, okay, I got it right. It helps if you draw a smaller diagram and then find the pattern and then apply the pattern to, because if you tried to figure out like 60 by 32, that would just be really difficult. Great job, Leanne.
Thanks for the help.
Yeah, no problem at all. You did great.